Hello students, welcome back to Engineers Academy. Now I am going to solve this example which is based on the projectile motion. In this problem we are given that a sake slides off this ramp which is shown in this figure with the horizontal velocity of 12 meters per second, right? So this sake slides off the ramp and it is released at this point A with the horizontal velocity, right? So the velocity is horizontal, right? So we can write that velocity, the initial velocity is horizontal, right? So let's say that this initial velocity is only acting in the x direction, right? And that is 12 meter per second. And this means that if the initial velocity is horizontal and it's not making any angle with the x-axis, so this means that v naught y, the initial component of the velocity in the y direction, is 0, right? Since it is acting only in the x direction. To solve this problem, first we have to define our coordinate system, that where our origin is, right? So let's say that this is our positive x and this is our positive y direction, and let's say that the release point is our origin, right? So let's say that this point A is our origin, right? So then if this is our origin, so then this release point has the coordinates of 0, 0, right? So if we write that the coordinates of point A, let's say that these points are x naught and y naught, right, at this point A. So this means that x naught is 0 and y naught is 0. So I can write that x naught is 0 meters and y naught is equal to 0 meters, right, if this is our origin. And when the sake reaches this point B, so what are the coordinates of this point B? So let's say that the coordinates at this point B are xb, yb, or let's say that the coordinates at this point are x and y, right? So as we can see that in this problem it is given that if the height of the ramp is 6 meters, so the height of the ramp from the ground is 6 meters, this is the height, right? So it is said that determine the time needed for the sake to strike the floor, right? So we have to find the time that the sake will take to reach this point B, to reach this ground, right? And the range R where sake begins to pile up, right? So we have to find this range R where these sakes will pile up, right? So we have to find this R, this range of this sakes, right? So as we can see that the horizontal distance of this point B from this origin is R, right? This range, we have to find this range. And since the positive y is in this direction, right, so this sake will travel 6 meters in the negative y direction, right? So we have to write that the y coordinate of this point B will be minus 6 meters, right? So this means that x is equal to r and y is equal to minus 6 meters, right? So these are the final coordinates and these are the initial coordinates, right? So now we can use only 3 equations. We have these 4 equations that I have derived already, so we can use in these 3 equations, any of 3 equations from these, right? So now if first we are required to find time, right, and then we are required to find the final position along x, right? So if we look into this equation, right, so this is the equation for the final position along x. This is x, right, and x is the final coordinates of the sake, right? So this x. So if we look into this equation, so there are 2 unknowns, one is time and one is x, right? So we cannot use this equation directly, right? And if in this problem we are not required to find vy, right? So we will not use this equation and we will not use this equation, right? So if we use this equation, so we are given y, right? This y is given, y naught is given, right? So y naught is given as well, and v naught y is given as well, right? So v naught y is 0, right? So this is 0, and similarly we can find t by using this equation, right? So if I use this equation, so this is y equals to y naught plus v naught yt plus half, and AC is minus g, right? So this is minus g into t square. So now if we put our knowns, right, so this y is equal to minus 6, so I will write minus 6, y naught is 0, so I will put 0, v naught y is 0, so this thing will become 0, right? So I can write 0, and this will become minus 1 divided by 2 into 9.81 into t square. So this means that minus 6 is equal to minus 1 by 2 into 9.81 into t square. So t square will be equal to, this will become positive, and then we will write that this is 2 into 6 divided by 9.81, and we will take the under the root. So this will give us the time required for the sake to reach this ground, right? So t comes out to be 1.11 seconds. So now we know t, so we can find that range by using this equation, right? So this, if we use this equation, right, so that equation is x equals to x naught plus vxt, right? So x, the final position of the sake at this point b, x is equal to r, right? So we can put x equals to r, and x naught is 0, and vx, this is v naught x, sorry, so v naught x, so v naught x is 12, right? So we can use this, this is 12 into the time, right? So this is 1.11. So r comes out to be 13.32 meters, right? So the sakes will pile up at a distance of 13.22 meters from this origin in the x direction. Now if the sake was released from rest at this point A, right, in this direction, and so the time for the sake to reach this point C will also be equal to this, exactly the same time, right? So this equation, while using this equation, this means that if we consider only the vertical motion of the sake from A to C, right, so as we can see that at this particular point the initial position of the sake in this direction from A to C is 0, right, and it will travel 6 meters in the negative y direction, so that is minus 6, and the velocity in the y direction at this particular point is 0, right? So if we release the sake at this particular point from 0 velocity, that is the 0 initial velocity, so it will take the same time, right, that is the 1.11 second to reach this point C. Now I am going to solve this example on the projectile motion. This is the second example, right? So in this example it is said that the track for this racing event was designed so that riders jumps off the slope at 30 degree, right? So this is the rider which jumps at 30 degree, right? And it is said that from a height of 1 meter, right? So this height is 1 meters, which is given in this diagram, which is drawn here, right? So during a race, it was observed that the rider shown in figure 1223A, so here is the rider which is shown in this figure, right, remained in air for 1.5 seconds, right, and he jumps from this ramp at 30 degree angle, right? So this angle is 30 degree, right, and let's say that at this point, at this particular point, the velocity is, let's say, VA, right, and the height of this ramp from the ground is 1 meter, right? So it is said that it takes the rider remained in mid-air for 1.5 seconds, right? So we are given the time. So time is 1.5 seconds, right? And it is said that determine the speed at which he was traveling up the ramp, right? So we have to find this VA velocity. So we do not know that VA velocity. This is not known, right? And it is said that find the horizontal distance he travels before striking the ground, right? So we have to find the horizontal distance. So let's say that that horizontal distance from this point A to this point is, let's say, r, right? So we have to find that r value and the maximum height he attains, right? So we have to find the maximum height, this height h that he attains, right? So the maximum height that he achieves, so we have to find that maximum height as well, right? So we can write that we are required to find this height h. And it is said that neglect the size of the bike and rider, right? So we have to neglect the size of the bike and the rider. So let's say that first we need to define our coordinate system. First we have to place our origin for our coordinate system, right? So let's say that the point where the rider jumps is our origin, right? So let's say that this point A is our origin and the coordinates at this point are 0 0, right, since it's our origin, and the positive x direction is in this direction and the positive y is vertically upward, right? Since the initial velocity, let's say that the initial velocity is VA and it is making 30 degree with the positive x-axis, so then this velocity will have two components, right? So this will be VAX and this will be VAY, right? And VAX will be equal to VA cos of 30 degrees, and similarly VAY will be equal to VA sine of 30. And when the rider reaches this point B, so what are the coordinates of this point B, right? So let's say that the coordinates at this point B are, let's say, XB and YB. And as we can see that the horizontal distance from this point A is, let's say, R, right? So then this means that XB is R and YB is, since the rider jumps at a distance of 1 meter from the ground and this is our origin, right? So then this means that this point B is at a distance of -1 meters from this point A, from this origin, right? So we can write that the final position is -1 meters, right, according to the origin. So this means that x naught, or we can say that at this point the coordinates are, let's say, XA, right? So let's say that XA equals to 0, YA equals to 0, and similarly XB equals to R and YB equals to -1 meters, right? So we are given these coordinates, right? So this is our the initial position is our origin, right? And these are the final position. So YB equals to YA, that is we are considering the vertical motion, right? So vertical motion. So YB equals to YA plus, that is the initial velocity in the y direction. So that will be VAY into T plus half AC into T square, right? So since we have the final position, that is YB, that is the initial position YA, and the time is known, right? So time is given, that is 1.5 seconds, right? So this is the time which is given, that is 1.5 seconds. So now we can find VA magnitude, right, the initial velocity magnitude. So YB is -1, right, and the y direction, the upward direction of y is considered as positive, right? So this is -1 meters, and YA is 0, and VAY is VA sine of 30. So we can write that this is VA sine of 30 degrees, and T is 1.5. And this AC will become -g, right? So this is plus 1 divided by 2 minus 9.81 into 1.5 whole square. So in this equation only VA is unknown, so this will give us VA. So this is equal to -1, this will be 1.5 VA sine of 30 degrees, and this comes out to be -11, right? Or we can write that -11.03, and we can simplify this. So then VA will be equal to -1 plus 11.03 divided by 1.5 sine of 30 degrees. So this will give us the initial velocity magnitude. So VA comes out to be, the initial velocity comes out to be 13.38 meter per second, or we can write that VA equals to 13.4 meter per second, right? So now we know the initial velocity. Now we are required to find the range. So range is, the R is in the horizontal direction, so we have to apply the horizontal motion equation, right? So if I write that, let's consider that horizontal motion. So in horizontal motion we have only one equation, right? So that is the final position equals to the initial position plus V naught x into t, right? So we have this equation. So now xb is equal to r and xa is 0, and V naught x is again VA cos of 30 degrees into 1.5 seconds. So r is equal to, so now we know VA magnitude, which is 13.38 cos of 30 degrees into 1.5 seconds, right? So this will give us the position of the rider from this origin in the x direction. This comes out to be 17.38 meters, or we can write that r is 17.4 meters. Now we are also asked to find this maximum height. So to find this maximum height, we will consider the final condition as point C, right? So we will consider the motion along this AC path, right? So now what are the coordinates of this point C? So let's say that the coordinates of this point C are XC and YC. So now the XC coordinate is not known, but YC coordinate is known, and YC coordinate is the this YC distance is from this origin, right? So from the ground, the distance is h, right? But from this origin, what is the distance, right? So this, we need to find this distance, right? So this distance, so this, the total distance from this point to this point is height h. So this distance will be h minus 1, right? So I can write that the coordinates of these points are xc, h minus 1, and xc is not known, right? So now we only know the final position in the vertical direction, right? So the initial position, so we will consider this motion, right? So again, if we write the initial conditions, so then we know that we will consider the vertical motion, right? So if I write the vertical motion, and that motion is from A to C, right? So again we can write that VA y is, now we know VAY, right? So VAY is 13.38 sine of 30 degrees, right? And the initial coordinates are, XA is known, which is 0, and XB, let me write XA and YA, which is 0. And now at this point, this is XC. So XC is not known, but YC is known, which is h minus 1. And we have to find this h, right? And the time is not known from A to C, right? So let me write that TAC is not known, right? Since for this part of the motion from A to C, the time is not known, right? So we will use that equation which do not have time in it, right? So we will use this equation, right? So this equation will be VCY square, which will be equal to, this is the final velocity in the y direction, and this will be the initial velocity in the y direction plus 2AC, and this will be YC minus YA, right? So when this rider will reach at this point C, so then this velocity vector will become horizontal, right? So let me draw that velocity vector. So at this point C, this will be the velocity vector, which will be horizontal, right? And this will be VC, right? So, and this is only the horizontal component, right? So this is VCX. So this means that at this particular point C, VCY will become 0. So this will become 0 at this particular point when the height is maximum, right? So when the rider has reached its maximum height, so then at that particular point, the vertical component of the velocity at that particular point will be 0, right? So we will write 0, and VAY is this thing, this is 13.38 sine of 30 degrees whole square, and this AC will become minus G, since we are considering the vertical motion, right? And the acceleration due to gravity is acting in the negative y direction, so we will write minus 9.81, and YC, as I have already told that YC will be h minus 1, right? So h minus 1 minus 0, right? So in this equation only the h is unknown, so we can find that maximum height using this equation. So we can write that minus 2 into 9.81 into h minus 1 is equal to minus 13.38 sine of 30 degrees whole square, and this minus will cancel out, and h minus 1 will be 13.38 whole square divided by 2 into 9.81. So h minus 1 comes out to be 2.28, and h will be equal to 1 plus 2.28, right? So 1 plus 2.28, which is the maximum height, comes out to be 3.28 meters, right? So the initial velocity is 13.4 meter per second, and the maximum height the rider will reach is 3.28 meter, and the horizontal distance, that is the maximum distance that he will travel in the x direction, that is equal to 17.4 meter. So this is the solution of this example.